Hi, wonderful viewers. It's my pleasure to welcome you on this channel. And today we'll be discussing the phenomenon of photoelectric effect. Now, I'll try to give a description of what photoelectric effect is, and then I'll also mention some of the devices where the phenomenon of photoelectric effect are applied in practical terms. Now, what is photoelectric effect? Photoelectric effect is defined as the emission or the liberation of electrons from the surface of a metal when light is incident on the surface of that metal. By implication, whenever light is incident on the surface of a metal, electrons tend to be liberated from that metal surface. Now, the electrons which are liberated by this incident light are called the photoelectrons. Now, in order to help us understand what photoelectric effect is, in order to give a clearer description of photoelectric effect, it is necessary that I spend some time to discuss the nature of light. Now, it has been established that light has two nature or dual nature. Now, these natures of light are the wave nature of light. Now, in wave nature of light, light manifests itself as a wave. Light manifests itself as an electromagnetic radiation. And the important parameters of wave is frequency and wavelength. Every wave must have frequency and must also have wavelength. Now, light, because it has frequency and wavelength, also carries energy. And the energy of light depends on the frequency. Similarly, the second manifestation of light, or the second nature of light, is what we call the particle nature of light. So, in as much as light behaves like a wave, light also has particle-like properties. And each particle or each packet of light is what we call the photon. So a photon can be seen as a particle or a quantum of light. Now, the energy of a photon is given by the equation E equal to hf, where E is the energy of the photon, F is the frequency of the photon, and H is a constant which we call the Planck's constant. Now, similarly, we can also write this equation in terms of the wavelength, because frequency is connected to the wavelength through the speed of light, and that gives us C equals to F lambda, where C is the speed of light. Hence, this equation can be written as E equals to hc over lambda. Now, lambda is the wavelength of the light. As we can see from this first equation, the energy of the photon E is directly proportional to the frequency of the photon. So the greater the photon frequency, the greater the energy of the photon. On the other hand, the energy of the photon is inversely proportional to the wavelength. Hence, the greater the wavelength, the smaller the energy, and vice versa. Now, when a photon of light falls on the surface of a metal, the electrons on the surface of the metal will absorb the energy. Of the photon. Now, what happens when this energy is absorbed depends on the quantity of the energy. If the energy is large enough, the electrons will be ejected from the metal surface and then given extra kinetic energy, so that the electrons will begin to move. Now, the liberation of electrons from this metal surface also depend on the property of the metal, and the property of the metal is quantified by a term called the work function of the metal. Now, results from experiments shows that the maximum kinetic energy of the electron liberated depends on the frequency of the photon. Now, this relationship is well explained by the Einstein photoelectric equation. Now, the Einstein photoelectric equation explains how the kinetic energy varies with the photon frequency. Now, photo cells can be used in the following devices. We have the television cameras, the automatic street light, and so on. Thank you for joining me.